solving LeetCode 45 jump game second version. It's also medium, and this one, to be honest, I found it a little bit difficult. I hope you will find it very easy. Okay, let's read the description. So, you are given a zero-indexed array of integers nums of length n. You are initially positioned at nums 0 index. Each element at nums I represents the maximum length of a forward jump from index I. In other words, you are at nums I, you can jump to any nums I plus j, where j is between 0 and nums I, and I plus j is less than n. Return the minimum number of jumps to reach nums n minus 1. The test cases are generated such that you can reach nums n minus 1. So we can always reach the end of the array with the jumps, but now we should return which path is the shortest, like how many jumps should we make to reach the end in the shortest path. If you remember, we covered a jump game first version. In that one, it asked us whether we can reach the end or not. And in this one, it says we can always reach the end, but return us the smallest number of jumps to do so. We have an example here, array of numbers as described. So the output is 2, meaning that the minimum number of jumps to reach the last index is to jump one step from index 0 to 1, then 3 steps to the last index. Okay. To 0 index to 1, and then 3 steps to the last. This is the shortest path. But if you pay attention, we have other paths like 2, 3, then we jump to 1, and we jump to 1, and we jump to 4. Or like 2, 3, and then we jump to the second one and jump 1, which will give us just 3 jumps, but the shortest one is 2. And here we have another example. Here it also says 2 is the answer. Let's see, we jump from 2 to 3 because jumping to 0 will not lead us to anywhere. And from 3 we jump to 4. And that makes sense. Okay. So how can we figure it out? And I believe we had a constraint here, which means j is less than 0 and nums I. I plus j. Okay. Okay. So, okay, let's just try to paraphrase the question in our words and come up with input and output cases. Maybe it will make the question more clearer, or it will be easier to find the answer. For me, it doesn't click right now. Let's try with more examples and description. So the input will be array of integers, and output will be integer shortest number of jumps till end. And constraints, we will always reach the end. There will not be invalid cases. The list length will be 1 or more, and the numbers inside the list can be 0 or more. And it's guaranteed, like again, it's saying there are no invalid cases. You can always reach the end, at least one way. Okay. So yeah, let's try. First input and output. right here, and here is another input and output. And let's try to understand the logic, what is happening here. When are we incrementing our count? First, we will start with like jumps 0 for sure. And our pointer, let me take this example, and actually right here, let me place it, and let me have this variable and place it here, and our index is here, and maybe we will have something like max range, something like that, interval or range. Okay, at the start it will be 0, but when we check this number, we see that we can go up until the number like nums I, which is current index, plus I itself, meaning that for this one we can go till 2. Our max range is 2. And now we have an option to choose from 3 or 1. And which one we choose actually makes the question tricky, like which one we choose. If we choose 1, our path becomes longer. If we choose 3, it will be shorter. Let's imagine we had another number here. In this case, the output we want to get is 3. We want to reach the response, let's say. Response is 3. We want to find a way how to calculate jumps so that it will only be 3. Okay, let's see. Should we also have something like current interval, or something like, not sure, maybe current interval, which will give us, or current interval range, something like that? Will it help? So when we reach 2, we have this current interval range up to 2, and max range is also up to 2. When we choose 3, let's imagine we choose 3 and we check our max range is going to be 3 plus the index of 3, which is 1, 4. We can say it's going to be 4, but we are still within our current interval range. Should we not update it and check next value? Maybe that works, because let's say we want to take the longest from the current interval, longest jump. And for that, if we had like 4 here, maybe we could have taken 4 and jumped till the end instead of taking 3. That's why I'm thinking like, let's check all the values that are in the current interval, if it makes sense, yeah? So the next one, here we have the index 2 and 1, which means we can jump until the index 3, which is right here. And index 3 is less than our max range, and we don't update it. And in the next iteration, we check that when we reach, we are actually going by 1, and like when we reach this index, we check that it's outside our current interval range, but it's within our max range. I feel like at this time we should update our current interval range as well, and keep checking this part. Like 1, we have index 0, 1, 2, 3, and 1, and 4. We don't update anything here. And then we have 4. 4 is index 4 plus 4, which is 8. But we are still within our current interval range. We don't update anything. And when we move to 2, it's the end actually. It's within our, not within our current interval range, but within our max range. Okay, if I take this example, feels like we are updating our jumps when current interval range is changing. Am I correct? Because we changed it, it was 0 at the start, and we changed it at when we reached 3, for example, because the current max range was 2 plus 0, which is like 2, and current interval range was 0. We came here, we checked that it's outside our range, we updated our range to max range. Maybe we should also update jumps here. And then we moved to 1 but didn't update our max range. Actually at 3 we also updated our max range to 4, but we didn't update our current interval because we were still inside the interval. And when we reached 1 also, we didn't update our interval, and when we reached the second one, we updated it to max range, current max range. But max range was not big, and when we updated it, let's say we update also the jumps, and when we reached 4, again we updated our current interval range. No, actually, just a second. 4, 1, 2, 3, 4. We didn't update it. We updated our max range to 8, and when we reached 2, we then updated our current interval range to the max range because it was our current ID was bigger than that, and we update our jumps. Does that work for other cases? I feel like when we update current interval, we can say that we made a jump. Because what I mean by that is like we are updating current interval range only when we choose the biggest max range of between the options. It's like when we had two options, which were 3 and 1, which gave us options 4 max range and 3. So we iterated both of them, and then when we skipped like we ended our interval, then we updated the biggest jump width within these choices was 4. We are only choosing the longest one. Okay, but will it work if I have like 0 here and 2 here? I want to make it so like when we are choosing this, we may choose 3, but 3 ends up at 0. And will it work for this case? Okay, first of all, let's think about the result for this case, correct result. So the correct result should be 2 to 3, 1 jump. Let me increment by 1, then 3 to 2. It will be 2 jumps, then from 2 to 4, 3, and 4 to 2, and then 4 jumps. 4 jumps is the correct answer. And if we reset our counters and start, at this start, we will have max range 0, and when we check this 2, we updated it 2. It's like update every time I plus nums I is bigger. Oops, let's not write it here, let's write it here, is bigger. Okay, and this one will be update every time I is bigger, like we are outside the range. Okay, and here we don't update current interval, but when we reach 3, we update current interval because it's less than our I. We update it to the max range. Update to max range. Okay, it will be 2 here, and the max range will be 4 for this I because it's bigger. Okay, and we move. We move our current, and we check we are still within the range, current interval range, and max range is 3 for this item. We do not update it. We just move our cursor and we check And now we are at index 3, which is bigger than our interval range. So we have to update our max range. And like when we update our current interval, we are updating jumps. Increment by 1 every time current interval updates. Let me say that. We have made 4 jumps when we update current interval to 4. And here we also update our max range, which will be, let me see, 3 plus 2, 5. And 5. Okay, our range is now, let's point with this current interval range. Our range is now here. Is that correct? 0, 1, 2, 3, 4. Yeah, that's correct. We check 2 and we move to 0, and here max range is 4 plus 0, which is 4. We don't update max range. We move to the current to the next element. Our I is now 5, meaning that current interval is less than I, and we update our current interval to max range, and we update our jumps, and we also update our max range, which will be 9 as the ID plus the number, and max range is 9. Okay, and our current interval is here. And when we move to, it's again our current interval is outside again, meaning that we have to update it, and we have to update jumps. And for range, we will have 6 plus 2, 8. We don't update range. And we are outside the loop now. Our range actually got bigger, and we are outside the loop. And we have jumps 4. Seems like the logic is working fine. Okay. So it is like getting the biggest interval between the intervals we have. It's like when we have 2, we have 3 or 1, and then we are choosing 3, which will give us this range. And within the ranges of 3, we are choosing again the biggest one, which will give us this range. And every time we are choosing the biggest range, we are updating our jumps. It's like for 2 at the start, we have this range, these 2 numbers, and between them we choose 3 and update our interval and say that we jump to 3. Jump is incremented, and then we have 3 numbers. We go through them one by one and choose the biggest range and also update our jump, meaning that we jump to 2 right here. And then we also have another choice of intervals like numbers, and we choose the biggest among them, and we choose 4, of course, and then we imagine we jump to 4 and choose the options. And then when we reach the end, it will be the biggest numbers. Yeah, it seems like this logic is working fine. For this one also, let's just quickly do it. 3 and 0, we will choose 3 because of our algorithm, and then 3 will provide us this interval, and when we are looping, we will reach the end, and automatically actually right here, is this a edge case for my let's try this one now. Let me take everything and try for this. We have these numbers, our current is here, our interval is here is 0, jumps is 0, max range is 0 at the start, and current interval is 0 at the start. And we start looping through our list. Here we have max range will be updated to 2, and we move, and here current interval is outside, like we stepped out, so we update it and update our jump. And then we let me show how we updated like current interval. It was 2, so we move it to 2, and then we check our max range. Here it will be 4, but we are within our range. Like we move, we are within our range, we don't update anything. The max range will not update because here we have 2 max 2 and it's less. We move our cursor like current item with and here we are outside the range. We update it to the max range, we update our jump, and we update our interval, of course, pointers. So our max range is now here, and here we have 3 plus 1, 4, which is not bigger. We don't do anything. We move. Here we have here we have a bigger range. Actually, it's 8, but we are within our current interval. And when we move out, the problem is we will say it's 2 jumps. Oh, it's not actually a problem. You see, because the answer was 2 jumps. Yeah. I was thinking like it should be 3, but it should actually be from 2 to 3 and from 3 to 4. So it's like the logic is working, and let's discuss the time and space complexity. Space complexity of this solution. Time complexity will be big O of n, because we are looking through the array only once. We have 2 pointers, 3 variables, and for space complexity we are not using anything other than these 3 constant variables, which are max range, current interval, and jumps count, which will be O of 1. At this point you can pause the video and try to code the logic, but otherwise I will go on and start coding. As always, I will write my pseudo codes, initialize variables which are max range, current interval, and jumps count. 3 variables I will have, and then loop through the array, and inside the loop I wanna check if current idx, actually index, is less than actually bigger than the interval, update interval, and also jump count, because every time we update interval we update jumps. Besides that, what we also do is like we always update max range if I plus nums I is bigger. I could have actually copy pasted there. Okay, are these the 3 steps we are doing? So we check the current, we update the current interval to the max range, and then we update max range, and we move on. And at the end we just return jumps. Okay, let's get coding. Let's start coding. Let max range equal to 0. Every one of them are actually equal to 0. Current interval equal to 0. Jumps count the same, equal to 0. Initialized at 0. And let's start our loop. For I is equal to 0, I is less than nums dot length, and I plus plus, we wanna do the following right here. Let me just write the return statement right now. Return jumps count Okay, we want to check the first statement. If I is bigger than current interval, please update current interval to be to the number of max range, and also increment the jumps count. Otherwise, we want to also check if I plus nums I is bigger than our max range. Update our max range. I plus nums I. That should be it. That should solve our problem. For a loop, okay, indentation inside the loop. Seems like it is fine. Let's try to run, dry run. Okay, so we will have this array starting at here. Oh, actually, let me write some line by line. I was doing this quick initialization, but it's not very helpful when I want to show it visually while dry running the function. So yeah, all of them are 0. I don't need this loop. And I don't need this explanation because it is pretty clear. Okay, and this one, let me write true or false. I will write here, and yeah, it's the same. We don't need this. Let's start. We are at index 0, which is 2. Max range and everything is 0. 0, 0, and 0. Is the current I, which is 0, bigger than current interval? False, because both of them are 0. And is the current I plus nums I, which is 0 plus 2, I 0, and nums 2 is 2, bigger than our current max range, which is true. So we update our max range to the number 2, to this number. Next, moving on, now we have index 1, the element is 3, is I bigger than current interval? I is 1, current interval is 0. This time it's true, it's bigger. If it's true, we want to set our current interval to the max range, which will be 2. Current max range is 2 because, and jumps also should be incremented to 1. And the next statement we check is I plus nums I bigger than max range, which is 1 plus 3, 4, is 4 bigger than 2. True, yeah, so we update our max range to be 4. Next iteration we have second 2 index, and item is 0, and we check is 2 bigger than our current interval 2, which is 2 actually. It's false, it's not bigger, it's the same. Then we check is max range. Our current max range is 4, and 0 plus 2 is 2. 2 is not bigger, it's false. We don't do anything, we skip. And the next number we have at index 3, which the number is 1. What about I? I is 3. Okay, is I bigger than our current interval, which is still 2? Yes, it is. True. Let's update our current interval to the current max range, which will be 4, and let's increment our jumps, which will be 2. And we also check this statement. We have nums I plus 1, which is 4. Is 4 bigger than 4? False. Next item, we have index 4, the item is 4, and we check is 4 bigger than 4 current interval? It's false. We skip. And then we check 4 plus 4, which is 8. Is 8 bigger than our current max range, which is 4? It is also it's true, and we update our max range to be 8. And we skip, like we end the loop here because I becomes 5 and it's bigger than the length. It's not less than the length, I mean. It's equal to the length, and we just return jumps count, which is actually 2 at the time being. Okay, let's try to run. Hopefully it works. Okay, great. Honestly speaking, I was very worried about this question. It was difficult for me, but as you can see, like as I said, I had no idea how to solve it at the start, but coming up with new output and input cases, also trying to recreate what's happening in the function helped me a lot to come up with a good answer and a very clean code. If you have any better solutions, feel free to comment, and if you have like your feedback is valuable, provide the feedback please. Okay, now it's time to check the solutions. Let's check solutions for JavaScript with the most likes. 6 plus. 6 plus is actually the number of languages they are using. No explanation. I don't really like it. Let's get some answers with a good explanation. Greedy solution. Okay, but no explanation here. So they are, I believe, doing the same alt move, max move. Alt move is the current interval we have, and they are max move, moving it only if, oh, here it's better. Yeah, let me do it. Math.max. It's always good to check others' answers, you see. You will always find something useful. Instead of this if loop, we could have just said this, and it would be beautiful. And here they check. Here they are checking after, so they are saying equal to, that's why. But we are checking before. In both cases works fine. Okay. Any other solutions? Very, very fast solution. Okay, let's see. Oh, he has a video explanation as well. He has left right response max mass.max. This one I understand, as this is our max range updating. Left equals to right plus 1, right equals to max, rest plus plus. I believe this is just another way of writing our solution, because I also have 3, left, right, and response. Left starts at 0, right is at 0. Both of them start at 0, and when do they update? Okay, I see. So it's like every time they are getting the current interval that we are taking. For example, they are getting, when they come to 2, where they have this interval, left is index 1, right is index 2, and they are iterating through the numbers within this interval, getting the biggest interval, and then iterating through that one. It's very similar approach to ours, but the coding is a bit different. Okay, let's also check actually the fastest solutions with less. My code is here, okay, and okay, this while loops are winning my code. Why is that? Do you have an explanation, please? If you know, leave the explanation in the comments. It will be very useful for me. I actually checked runtime, and for memory, let's check the best ones. I wanna cry because mine is also the same. Let me I can submit my answer because I have this max updated, as you can see. And now, am I in top? No, but the person with the same solution is on top. Yeah, that's why, like, this is not very reliable. Is this line changing everything? I have an idea. Let's copy paste and see whether we can reach that ultimate answer. No, you see, it's unfair. I'm here now, but the answer is here. Okay, LeetCode. That's not fair. Okay, and thanks for watching this video. Please like and subscribe. Have a nice day. Keep coding.